This meeting is being recorded.
The first problem from Chapter 1, 1.1, asks us to draw all of the constitutional isomers with these molecular formulas. So constitutional isomers are what we're looking for. So if you recall, that means that we're going to have some different connections of our atoms. So they're going to be bonded in different ways. So we're going to figure out what the total number of different ways we can connect these atoms will be. So for A here, let's first look at the valency of each of these atoms. And what I mean by that is that carbon has 4 valence electrons and it tends to form 4 bonds, whether those are single, double, or triple. It always has 4. Hydrogen will form 1 bond. It's monovalent, and so is chlorine. So we have monovalent. And over here, carbon is tetravalent. So we're going to use this information to help us predict where we should place these atoms to find all the different arrangements that we can. So let's put the highest bonding in the middle. So we have 3 carbons in a row. All of our singly bonded atoms, such as hydrogen, can go around the carbons, and then we can place the chlorine on this end here. So this is one constitutional isomer. Let's see if we can find another. So if I again put my carbons in the middle, I can surround them with hydrogens, and then instead I'll place the chlorine on this central carbon. So I can try to figure out where else I could place that chlorine, because that's really the only difference between one constitutional isomer to the other in this C3H7Cl molecular formula. So if I try, I would find that no matter where I place the chlorine, it would be a mirror image of one of these 2 isomers already, whether through rotation or bond rotation or rotation of the molecule itself. So that's it for A. Let's take a look at B here. I'll draw a little dividing line. So B, now we have C4H10. So again, we'll start with our carbon chains. We'll place hydrogens all around. And this will be our first constitutional isomer for the chemical formula, C4H10. And then this is an unbranched linear hydrocarbon chain, but we can have some branching, right? So we can have one of those carbons come off the side here, and then we'll have a 3-carbon chain with a methyl substituent or methyl side chain. So our second constitutional isomer, right? And we'll make sure we have 3, 6, 9, 10 hydrogens in both. Will be this structure here. So if you try to rearrange the carbons in any other manner, you'll find that you are limited to only 2 constitutional isomers for C4H10. So try these additional 3 problems and see if you can find more than 2 constitutional isomers.